Hi there everyone, and my name is Christian, this is my name, and I'll be discussing you about circle theorem and area theorem. But by the way, I just want to introduce my buddy. It's Angelo Saher, the one who's holding the camera. I'm Poggy. As I told you a while ago, I'm going to discuss the circle theorem and area theorem. This is a part of our requirements in finals in analytical geometry. So now we prefer to discuss first the circle theorem. Circle theorem. Circle. Sorry for my penmanship. Theorem. Hope you understand that, guys. And circle theorem. And in order to draw a circle, we need a tool, this compass. We use this to draw a perfect circle. But in our case now, I'm using a whiteboard marker, and I can't attach the whiteboard marker on my compass. That's why I'm going to use type ng kaldero. Alternative way. So, okay. I'm going to draw a circle now. Just putting the takip ng kaldero on the board. As simple as this. And there you go. Okay, assume that it's already perfect. And now I'm going to name this circle as circle Y. This circle Y because the center is named Y. Okay, now I'll be discussing the lines that we can find inside and out the circle. First, I'm going to discuss radius. What is radius? A radius is a line that hit the circumference. By the way, this is circumference of the circle. Yeah. And the radius is the line that passing through, or rather hit the circumference and from circumference until the middle of the circle. This is what we call radius. Okay. And if I'm going to extend this radius, it will be now and hit the another circumference again. This line already passing through the middle of the circle, and we're going to call this now diameter. Okay, and to make it easy to remember, 2 radius is equal to 1 diameter. Okay. I'm going to erase it now. It's really hard to erase these things. We're just using a alternative whiteboard, so we really want to use alternative ways because we're not that prepared. Sorry for that. Anyway, sorry sir, we commit erasures again. And I'm going to bring back the center Y. So after the radius and diameter, I'm going to discuss now what is chord. The chord is a line that still hit the 2 circumference, but in this case, chord doesn't passing through the center of the circle, just like this one. This is what we call chord. Okay, I'm going to erase it now. Hope that you're getting the important points that you should get. Okay. Radius. We're now done with radius, chord, and diameter. Now I'm going to discuss secant. Secant is a line that hit, or rather passing through the circle. Compared to to a chord and on the two circumference. As I told you a while ago, this is circumference, and secant is passing through. Secant just not just end in the circumference. Okay, and don't be confused on it. This is the chord and this is the secant. Secant. Okay. Erase, erase. Erase, erase. So now I'm going to create a new circle now. So I think I need to erase it all by using alcohol. It's really hard. I'm having difficult time to erase those things. So I'm going to use alcohol. And now I'm ready to someone's text me. Someone's missing me a lot. Okay. I'm going to create a new circle again. Yeah. Circle. Circle. Okay. Now I'm going to name the circle as circle X. Okay, because the middle is named X. Excuse me. Last line that I wasn't able to discuss before is the tangent line. I'm going to create now a line here. Oh my gosh. This is a tangent line. The line that can we find out the circle, and it only hit one point at the circumference of the circle. So this is the point that hit by the tangent line. So this point we call this point of tangency. Tangency. This point is only a one point. Okay. So I hope that you're getting the point, or getting some knowledge on it. Anyway, I'll be discussing I don't think that this is a mystery, but for me, correct me if I'm wrong, for me this is a mystery because not all students studying in circle or studying geometry know this. From this point, I'm going to create a radius. As I told you a while ago, from the circumference of the circle until the center of the circle. Okay, that's a radius. Now, this is the tangent. This line, tangent line, and this is the point of tangency. And the mystery behind it is the tangent line creating 90 degrees and 90 degrees using the radius that I was created here, and it's automatically creating 90 degrees. So this sign is a symbol of 90 degrees. So that's another point that we should consider, or we should remember. And now I'm going to erase this. Erase. Going to erase again. Sorry for inconvenience. It's already dirty now, so I'm going to use alcohol again. Hope you appreciate my effort in erasing those things. Okay. Now, going back, I'm going to draw a circle again using tak na kaldero. Don't try this at home. your mother might be get mad at you. Okay. Now, and here's the center. Don't try to forget the putting a point in the circle. It's very important. Anyway, now I'm going to discuss angles inside the circle. So first, I'm going to draw a. I'm going to draw an angle like this one. Angle. Again, distraction. Okay. And I'm going to name this angle as angle A, B, and C. Okay. Whenever you see these angles, or whenever you see this kind of angle inside a circle, always put it in your mind that this is what we call apex angle, or apex vertex rather. Vertex. Okay. And in this apex vertex, I'm going to plot now a new angle. Now, at this time, I'm going to use the center of the circle. Center of the circle. Okay. So, this is the angle number 1, or angle number 2. So let's assume that this circle, the center of the circle, is x again. Okay. We can now see two angles: the angle ABC, angle AB, and angle AXC. Angle AXC. So we already have two vertex. This is B here, B, and X. This X. And now I'm going to tell you something, or additional knowledge in it. Okay. I'm going to erase this first so that it will be clear for you guys. Okay. Let's assume that this angle B is equal to, let's assume that angle B is equal to give me figures, buddy. Angle B is equal to 30, let's say 30. Okay. In circle theorem, automatically, what the size of the vertex B, this one, or the angle B rather, will not just equal on the angle X. It will be angle X multiplied by 2, because this angle is now, the vertex of this angle is at the middle of the circle. So 30 times 2 will give us 60. So this angle now measures 60 degrees. But take note that we should make sure that both angle facing same arc. By the way, this is the arc, and that arc makes this angle similar because both of these angles facing only one arc. Okay, I'm going to erase now. Moving on, I'm going to use alcohol. We're still on the circle theorem. Okay. Now I'm going to, we're not yet done, I'm going to draw a circle again. Endless circle. Okay. And there's the center. Now let's assume that this circle A. Okay. I'm just going to make it here so that the circumference will be highlighted. Okay. Assume that this is already perfect. Anyway, moving on. I'm going to create now two parallel lines inside the circle. So one line and two lines. So I told you a while ago, this line is called chord because this line doesn't pass through to the center of the circle and hit the circumference until the circumference. Anyway, these parallel lines, I'm going to make a diagonal on it from this point up to this point. Okay, and another line, another diagonal from this point to this point. Now we can see what do you call this? Diagonals. Okay. Excuse me. Now as we can see, we already have, you can see a lot of vertex, but this is the major vertex is A, or sorry, we already used A. Going to erase this, change it by B. Here's our center A, B, C, D, D, and E. Okay. So our major vertex here now is vertex B, C, here the B, C, D, this one, and last E. So this is a major vertex, 1, 2, 3, and 4. Now, excuse me. The measure of this angle, like for example, congruent vertex. Like for example, this vertex. No matter what will be the measure of this vertex, will be also congruent to this vertex. This is according to circle theorem. So for example, this vertex measures 40 degrees, just an example, but in reality I don't think that this measures 40 degrees. It just might be 10 or 20 below. And since let's assume that this is 40 degrees angle, it automatically measures 40 degrees because they came from the parallel sides and two diagonals. Okay, and same as this one. If it's measured 10 degrees, now automatically this will be 10 degrees also. Okay. Excuse me. Geometry is so fun, and hope that you find it easy. I'm going to use a eraser again. I already committed a lot of erasures, so probably Sir Kagitla already mad at me at this point of time. Anyway, moving on. I'm going to create now I'm going to draw a figure, or a shape rather. I don't, wait. Okay, here's our circle again. A new circle, clean circle, hopefully. Now, this is our center of our circle. I'm going to name it O. Okay. Now, I'm going to put a shape inside the circle. So, I'm going to use this. I'm going to use this one. Oh my gosh. It's starting to get dry. Our whiteboard marker already started to get dry. Anyway, before it ends, I'm going to make it clear for you. I'm going to draw a shape inside the circle. Now, here's already, and I'm going to make this, excuse me, equilateral A, B, C, and D. So the mystery behind it, according again to circle theorem, the angle or the corner, like for example, this corner is across this corner, okay, and this corner is across this corner. So both both corners facing each other is equivalent to 180 degrees. That's according to circle theorem. So, like for example, we going to say that this is 80 degrees. So this corner C facing A. So since we have 80 here, the vertex C measures 80 degrees. So as a complement to make the 180 degrees, it's corner A now automatically measure 100 degrees. So if you're going to add this one, this corner and this corner, those vertex equivalent to 180. It's according to circle theorem, and no doubt on it. I've already tried so many times. Now, same as this two, if these two angles facing each other, and if it will be measured 110 degrees, now as a complement to make 180 degrees, angle D will automatically measures how many? 70 degrees. Okay, so just think of it. Both angles facing each other is equivalent to 180. Okay, and that's the the knowledge and the explanation in circle theorem, and hope that you got a lot of things, and we help you to be knowledgeable in circle theorem. And thank you guys.